From ebook readers to those digital price tags at the grocery store, you've likely come across e-paper displays. Today I'm gonna show you how to get one up and running with an ESP32. But first, let's find out how this amazing piece of tech actually works. So let's get started and put one under a microscope to find out. Under the lens, we can see randomly scattered tiny bubbles. Inside each of these is a clear fluid filled with millions of electrically charged particles, specifically white titanium dioxide and black carbon. These sit on a grid made of millions of individual pixel electrodes. On top we have a transparent conductive cover. Now here's where the magic happens. When the electrode underneath applies a positive charge, the negatively charged white particles are pulled down to the bottom. At the same time, the oppositely charged black particles are repelled and float up toward the top. That's what creates a dark spot on your screen. The best part is that even if we take the charge away, those particles just stay suspended right where they are. By applying extremely short electrical pulses, the controller can stop particles mid-flight. Because the internal fluid is highly viscous, the particles remain in a mixed state between top and bottom, which our eyes see as gray. You can also buy e-ink displays with 3 or more colors. Along with black and white, these use larger, heavier color pigments stored in tiny hexagonal structures called microcups. Because of their higher mass and size, they move much more slowly than the black particles. So the smaller black particles easily surpass them and reach the surface first, resulting in a black spot. However, we can isolate the third color by rapidly alternating the electric field. Then the lighter black and white particles are whirled around in the fluid, while the sluggish color particles remain relatively unaffected, allowing them to slowly migrate to the surface and take over the pixel. So unlike black and white displays, color displays take longer to update than black and white ones, and the timing is also more complicated. But don't worry, you don't have to deal with any of that. The display's firmware handles it all for you. The more colors an e-paper has, the longer it takes to update. The 4-color e-paper you see here needs about 40 seconds for a full refresh. It kind of reminds me of a Polaroid photo developing. Anyone who grew up before the 2000s knows what I mean. E-paper panels are connected to their driver circuits through a 24-pin FPC pigtail. Here's the pin out. They are typically controlled via SPI. It's also necessary to provide both positive and negative driving voltages, usually around 25 volts, to generate the electric field that moves the particles. This is usually handled by a boost converter circuit. And if you want to drive the e-paper with 5V TTL devices like AVR-based Arduinos, you also need a level shifter and a voltage regulator, since e-paper panels accept only 3.3 volts for both supply and input signals. No worries, you don't have to solder this yourself. This is why manufacturers offer ready-to-go driver boards like this Waveshare e-paper driver head. It fits perfectly onto Raspberry Pi Zero, but thanks to the included breakout cables you can use it with pretty much any microcontroller that speaks SPI. And you can minimize wiring even more. Waveshare also sells a development board that integrates an ESP32 and all the circuitry needed to drive an e-paper. Just connect it to the pigtail and you're ready to go. Or you can simply choose an e-paper module with the driver head already integrated. But if you decide to build all the electronics yourself, this is where my longtime partner PCBWay comes in. Building circuits on messy breadboards can get frustrating, so why not order a custom PCB instead? Just design your layout, send them the Gerber files, specify your requirements, and a few days later the boards will arrive. I really like the quality of the PCBs, which is why I enjoy working with PCBWay. Soldering is always fun and done in no time, even for beginners. And PCBWay not only makes PCBs, they also offer CNC machining, sheet metal fabrication, 3D printing and injection molding. Everything you need for your projects in one place, so give them a try. Okay, let's get an image onto this 7.5-inch display. I've got it connected to the e-paper head and an ESP32. To figure out the next steps, Just head over to the Waveshare wiki. You'll find all the displays there, sorted by size. Just find your model and give it a click. This brings us to its manual. By clicking on the tiles, we can jump directly to the section where the configuration for each platform is explained. It starts with instructions for Raspberry Pi, but of course there are also guides and examples for Arduino, Jetson Nano and related, and also STM32 boards. However, the ESP32 and 8266 are missing there. Instead, when we expand it, we find two links that bring us to the documentation for their driver boards. The ESP32 driver board contains both the driver circuits for the e-paper and the ESP32 chip. You don't need to buy it if you already have an e-paper head and a dev module like I do. Just hook up the pins like shown in the table and you're good to go. It works exactly the same. The newer revision 2.3 has an additional pin that isn't mentioned here. So what does that extra pin actually do? Let's have a look at the schematic again. When you tie it to VCC, the high side switch Q31 turns on and supplies power to the e-paper and the rest of the board. But when you pull that pin down to ground, the switch cuts the supply voltage off and the quiescent current drops to almost zero. So pull that pin to VCC when the display should be updating and to ground when it's idle. For our test, we'll connect it to the enable pin of the ESP32 dev module. That pin is permanently pulled to 3.3 volts through a 10 kilo ohm resistor and pulled to ground whenever you press the reset button. On both the driver board and the driver head, there's a small switch that sets the driving voltage for the color particles. The table shows the correct position for your specific display. If it's set wrong, you'll get low contrast or some pretty strange behavior. For the 7.5-inch e-paper, that switch needs to be in position B. There's a second switch that lets you choose between 3-line and 4-line SPI. Set it to position 0 for 4-line SPI, even though in our case we are only using 3 of the 4 lines. Now that everything's set up, let's run one of the examples. Click the download link and save the 7-zip archive. Inside, you'll find 3 different examples. We are going to start with the first one, so just copy the folder into your Arduino's project directory and open the sketch. Once it's open, just click over to the tab for the header file named srvh.h. This is where you'll configure your SSID, password and IP address to match your local network. Once that's done, just hit compile and upload. The sketch hosts a web server right on the ESP32 that you can reach under the IP address we just set up. On the sidebar, find and check your display. Then drag your image file right in. Just a quick heads up, your image needs to match the display's resolution exactly, since this demo won't scale it for you. If you click one of the buttons on the left, you can convert the image into a format the display can actually handle. Clicking this one gives us a black and white version, which you can preview right down here. Clicking Dithering Mono generates a dithered image that mimics grayscale. Finally, just click Upload Image to send it over to the display. The next example works with an Android app that uses Bluetooth to send the images. Install the app using the Android package file that's in the archive. Copy this file into the download folder of your phone's file system, then tap it to start the installation. After that, copy the Arduino sketch from the archive to the Arduino sketch folder, then compile and upload it to the ESP32. Just like we did in the web example, start by picking your specific display model in the app so it knows what it's working with. Then you can grab any image you want to send directly from your gallery or file manager. The app lets you crop the photo to fit the screen perfectly, and you can still choose between a simple black and white look or that cool dithered effect that we saw earlier. Once you're happy with the preview, just hit Upload Image. The app handles the Bluetooth transfer, and your e-paper will update as soon as the transfer is finished. The third and last example is for those who want to write their own code. To get started, open the example directory and, in another Explorer window, open your Arduino user library folder. Then simply drag the subfolder from the examples over to the other Explorer window. Once it's in place, open the Arduino IDE, go to File, then Examples, and scroll down to Waveshare ePaper. There's a massive list of supported panels here, so just pick the one that matches your hardware. We are using the 7.5-inch V2, so select it here. This opens a new window with the main code and all the supporting header files ready to go. I don't want to explain the example in too much detail, but if you scroll down a bit, you'll see that it provides basic drawing functions for circles, rectangles, and other geometric shapes. And it can also display bitmaps. These are defined in a byte array in a separate file. Each byte represents 8 pixels in a row, where a 0 plots a black pixel and a 1 plots a white pixel. With this, for our 800 by 480 display, the array has a size of 48 kilobytes. If you want to bring your own bitmaps to the screen, you first have to convert them into C arrays. Waveshare actually provides a converter app for this, but as you can tell from the design, it's more than 20 years old. It also only supports basic black and white, so there's no option for dithering. So you need another tool for this. I recommend the website Dithering Studio. Once you upload your photo, you can experiment with different algorithms like Sierra and try which one looks best. To my eyes, the default Floyd Steinberg gives the cleanest result, so I'll stick with that. You can also adjust how coarse the dithering is, but I prefer to keep it as fine as possible for the best detail. You can also fine-tune the look by bumping up the contrast or adjusting the midtones with the gamma slider, and there are plenty of other settings to play with. Once you're happy with the real-time preview, just hit download and save the result as a JPEG. To keep things compatible with the converter tool, just make sure to remove the E from the file extension. Now, back in the image converter tool, set the output file type to C array and enter the resolution of your display. Then, make sure that none of the checkboxes below are selected. Finally, save the header file into the same folder as your demo script and name it house.h. A text editor automatically opens to show you the generated byte array. Just make sure to take note of the array's name, because we are gonna need it in just a minute. In the Arduino sketch, include the header file you just created and call the draw bitmap function with the array name we just noted. To wrap things up, I'm using a rectangle, 2 circles and some text to draw a custom label right over the image. To prevent the program from running into a next section, you can simply add a return statement here or delete the remaining code. And here is how it turns out. Strangely enough, the image came out as a negative. But you can fix this easily by going back to the converter app and checking the reverse color box. This flips the preview, and since the library function performs another inversion, the final result on the display comes out as a perfect positive. There's another library that can be easily installed through the Arduino Library Manager. ESP32. It is mainly designed to support displays from a company named Good Display, but Waveshare and others use identical panels, so the library works with these as well. ESP32 relies on the Adafruit GFX library, so it will be installed automatically as a dependency. This allows you to use all the standard Adafruit functions for drawing shapes and bitmaps. Check out the online documentation for more details. And in this video, I show you how to build a super handy e-paper dashboard, a silent companion through the hectic everyday life. Thanks for watching. See you in the next one.